Well, because you are now understanding some of the characteristics of light, it behooves me to explain to you how a lunar eclipse works. I would be remiss if I did not inform you of such, and in any case, it's something that you will see in subsequent years. Even if you're trying to forget all the physics you learned, you'll still be reminded that, hey, tonight's a lunar eclipse, or next week, or whenever. And so it consists of the sun, called Sol, Earth, and the moon. Those three bodies involved. And the Earth blocks some of the rays of the sun. So here's the sun, there's the Earth, and the Earth casts a shadow onto the moon as the moon goes into the shadow of Earth as it orbits the Earth. Well, the penumbra is a partial shadow, since some of the sunlight can still reach the region. So this is the way to outline that geometry. If you strike lines like this shows, then this is the penumbra region, and actually within that there is a region that's not just the penumbra, as I'll mention in a moment. But if you put yourself right on this line, if you were an observer here, you would see this edge and certainly all the rest of the sun. You'd see all the sun. Here, you only see part of the sun, that part upward, etc. And so this is, in general, a region where you can see part of it. Now, the umbra is where the Earth blocks all the rays from the sun. And that geometry can be seen this way. All right, so that region where the sun is shining on the Earth and you're behind the Earth in such a way that you don't see any part of the sun. So you'd see all of it here, part of it, part of it, part of it, until you see none of it here. All right, so that's hopefully pretty clear. This is what's really cool, is when you get in the umbra region, because it really has a significant impact on how the moon looks. It gets quite dark actually, but not completely. And in fact, the moon ends up looking kind of a reddish color. And I want to explain that to you, because you know the concepts of refraction and scattering and reflection. And so those are the principles involved. Let's check it out. And so the story about why we see a reddish moon during totality. We have sunlight, and we can consider it parallel rays, even though it's slightly angled. And the light from the sun has all the colors in it. This is white light, essentially. And then there is our moon. Of course, these are not to scale. The moon would be a lot further away based on the relative sizes, even though the size of the moon here I have approximately correct compared to the Earth. So here's the atmosphere of Earth. And the Earth's atmosphere, as you know, has an index of refraction that's not quite like a vacuum. But first, let's look at we see the umbral region here, the totally dark, totally, quote unquote, dark umbral region, where the moon doesn't see any of the sunlight. And yet, even in that condition, we see that the moon looks a little bit red. Well, here's two of the rays coming in that are hitting the atmosphere. Now, the Earth's atmosphere is like a lens which refracts the sunlight. And the reason is because here the vacuum of space has an index of refraction of 1, and the atmosphere is something like 1.001 or 1.007 or something like that. Anyway, it's not quite 1. So it's a slower medium, and it bends the rays into the umbral region. So there they are. So there is refracted light from the sun. But it's not just the white light. I mean, it's not just regular, unaltered sunlight, because you've got the oxygen and nitrogen molecules of the atmosphere, and they are scattering the blue light, as we've learned. So blue light is scattered out. So this is a really significant sunset light situation. So as it traverses this whole atmosphere, and there's a lot of it, it's highly reddened. So, even though the moon is eclipsed, it's actually, the rays of light are bent into the umbra. They reflect red light to our eyes. So there's the refraction, there's the reflection after you've scattered the blue light out, and that is the actual sunlight that's coming to the eyes of the bipedal primates sitting here in the dark. Supposedly it's nighttime, but we see that reflected light from the sun off the moon. And isn't that an interesting little sequence of connections that are consistent with what we learned? Hope you found that interesting.